the next function we're going to look at in a little bit more detail, our quadratic, which of course when we draw it becomes the parabola. So some definitions. Now, a quadratic polynomial is just an algebraic expression. So ax squared plus bx plus c. So technically that's the quadratic polynomial. The quadratic function is when we make it equal to some other pronumeral. So y equals is usually what we see, but y equals ax squared plus bx plus c. So that's the quadratic function. And then there's the quadratic equation, where instead of making it equal to a pronumeral, we make it equal to a number, usually 0. So ax squared plus bx plus c equals 0. So that's the subtle differences in the terminology there. They're all quadratics, of course. Coefficients, well, that's same as always. A, B and C, so the numbers in front of, or what they're multiplied by, the pronumerals. Indeterminate. Not an expression you see that much anymore, but it's basically the x value. It's called the indeterminate because that's what you substitute into. So you can't determine its value. You actually give it a value. Roots. The roots are the solutions to the equation, as opposed to the zeros. The zeros are the x-intercept of the function, or another way of thinking of it, it's the x's that makes the polynomial equal to 0. Yes, they are exactly the same thing, but technically you have roots of an equation, zeros of a function or a polynomial. So find the roots of x squared minus 1, all it's really saying is solve the equation. Ooh, that's a bit tricky. X squared equals 1. Plus or minus 1. There you go. Alright, the graph. And as we know, that when we graph a quadratic, we get a parabola. But by looking at the equation, we can get certain information. So ax squared plus bx plus c. A, first of all, tells me about its concavity. So a happy parabola, well, that's when A is positive, because when you're positive, you're happy. And that's what we call concave up. And when we're unhappy, that's when we're a bit negative about things. So A is less than 0, concave down. Now B by itself doesn't tell us a lot. So let's just jump to C. C, the constant, as it is with any polynomial, the y-intercept. So that's what C does. The zeros or the roots, well, they'll end up being the x-intercepts. As I say, B by itself doesn't tell us a lot, but in this form it does tell us something. So minus B on 2A, that's our axis of symmetry of a parabola. Another way of working out the axis of symmetry, if you already know the zeros, just average them out. Because it's always going to be the average of the roots or the zeros. Vertex, well, we know the x value will be the axis of symmetry. And then the y value, we sub that in. Okay. Just something on terminology here. If they ask you to find the minimum or maximum value, they're simply asking for the y value. Okay? So you don't give the coordinates of the point, because if you give the x value and the y value, well, which one's the maximum value? They don't know. So you only give the y value. If they say, what's the maximum or what's the minimum? It's the y value. Alright, let's graph this one. Now, I'm not saying you'd write this down, but these are the sorts of things we look at to help graph it. A is 1, that's a positive number. I know I've got a concave up parabola. C is 12, so the y-intercept, I'll just plot that in. The zeros, if I solve that equation, I end up with negative 2 and 6. So we'll plot those 2 points in. Axis of symmetry, I'm going to draw it in. You don't normally draw it in on a parabola, but for the sake of the example, I'm going to draw it in. So minus b on 2a, which is negative 4, Or as I say, I could have just averaged the x-intercepts. Average those, again we get -4. So somewhere on that axis of symmetry will be the vertex. So if I substitute in, we get a y value of -4. So let's plot that point. That should be enough, I think, to draw our parabola. We want to find the quadratic which has roots 3 and 6. Okay. Well, there's my solution straight away. Now, how did I get that? Well, I know that if I factorise it, it would be x minus 3, x minus 6. I could do it that way. The quicker way I do it, though, is I say, well, 6 times 3 is 18. Because remember, you would have said, what multiplies together to give the last number? When you're looking for the two numbers. Well, you know the two numbers are 3 and 6. So whatever they multiply together must be the last number. And then we'd say, what adds together to give the middle one? Got to be careful though, it's going to be the negative of that. It's going to be the negative, because when you factorise, you'll go x minus that number, and then solve it, and you get x equals the positive of it. So minus the sum. So that's the quickest way of working out the quadratic. The coefficient of x will always be minus the sum. The constant number will always be the product. I put a out the front because of course it could be any multiple times that would also have the solution 3 and 6. So if I've got one like this, now it's going to be a heck of a lot easier to use this for idea over here than to expand out x minus 3 minus root 2 times x minus 3 plus root 2. I can simply say, well, hang on, add them together, the root 2's cancel, I get 6, so I know it's minus 6x. Product, difference of two squares. So 9 minus 2 is 7, and there's 7. In this case, you'll see this word monic. Monic means the coefficient of x squared is 1. Coefficient of x squared is 1. Okay. I'm told the roots are 2 and 8. Vertex is 5, 3. So in this case, it could be some constant times it, but again, add them together, I get 10, so I know it's minus 10x. Multiply them together, I get 16. In this case, I can actually work out what a is, because it's given me some additional information. I can substitute in the point 5, 3, and we end up with a is -1/3. This is my y. You might remember we looked at this earlier, quadratic inequalities. If I want to solve this, what we're basically saying is, when is this parabola above the x-axis? So I factorise it as normal. It gets me the critical points to the solution. So I know the critical points to the solution are -2 and -3. Alright, now those points are not included because it's just a greater than. If I was to draw this parabola in, then we're saying, alright, so what values of x is it above the axis? Well, that's when x is less than -3, x is greater than -2. So some people like to do it that way. Some people just like to test a point and see if it works. So you've got -3, -2. If I was to test the point 0, for instance, 6 is greater than 0. Yeah, it is. So I know 0 is included. So that gets me x is greater than -2. I'm just testing the regions. Let's try this one. Personally, I'm going to rearrange that and make x squared positive. I just prefer the x squared's being positive. So this time my critical points, 1 and -4. They're included this time. So when are we below? Well, that's in between 1 and -4. Okay. Alrighty.